Hello everyone, today we are going to be solving a work energy problem in physics. And this specific problem says that we are designing a jungle swinging sequence for the latest Tarzan movie um, to determine its speed at the low point of the swing and to make sure it does not exceed mandatory safety limits. We want to model a system of Tarzan and the vine as a pendulum. And we're going to have a particle in our system, which is going to be Tarzan, and he has a mass of 100 kilograms. And he's going to be hanging from a light string, which is our vine, and it has a length L attached to a support. The angle between the vertical and the string is written as theta, which in this free body diagram you can see this is the string I have, which has the length of L, and this is theta. And so part A asks us to draw the free body diagram of Tarzan on the vine, which I have right here. I have, this is the string, this is his path, this is the force due to gravity, and this is theta. This is also theta. But yeah, this is his path. So this is like technically like delta R, if you think about it, right here. This is going to be his change in position as he swings. And so, yeah, this is specifically just the free body diagram. Shows this is Tarzan right here, by the way. This little dot, Tarzan. And part B says, an infinestesimal distance along the arc the object travels is LD theta. Write an expression for the total work done on the particles as it traverses that distance for an arbitrary angle theta. Okay, so we know that work is equal to the force times the displacement. And for this specific problem, our force is the mass of Tarzan times his weight times the sine of theta, because that is in the y direction, because the only force acting on him is gravity, which is pulling down in the y direction. So that's why we're using sine here. And then times the displacement, which we were given in this. Object travels is LD theta. So this is his displacement. And so we can rewrite this as mg times L times sine theta times d theta. But these are both right. And these are formulas you can use to find the work done on the particle, which is Tarzan. And part C says, if the length is 7 meters and the particle starts from rest at an angle of 50 degrees, determine its kinetic energy and speed at the low point of the swing using work-kinetic-energy theorem. So we want to find the kinetic energy. So we know that the loss in potential is equal to the change in kinetic. They go hand in hand. And so our loss in potential is his mass times gravity times the length times 1 minus the cosine of the angle. And that is equal to the change in kinetic. And this is the kinetic, this is the final kinetic, and this is the initial kinetic. However, since this is the initial kinetic, the problem specifically states starts from rest. So this is 0. So this is not even important anymore. So now we just want to plug in. So the kinetic energy is going to be equal to the mass, which is 100, times gravity, which is 9.8, times the length, which is 7, times 1 minus cosine of the angle, which is 50. And we get 2,450.5 joules, or 2.5 kilojoules. Now we want to find the velocity, and we know that the potential is also equal to 1/2 mv squared. So 1/2 mv squared is equal to our kinetic energy. And so I basically just solved for v here. So v is equal to 2 times the kinetic over the mass, all square rooted. And so plugging in we get that his velocity at the lowest point is 7 meters per second. Thank you, everyone. Have a good day.